We are continuing our discussion about how to make distance corrections for different factors such as incorrect tape length, temperature, and now we're going to talk about slope. In the past, we've already done a review of trigonometry and we've determined a way to find a horizontal distance if we have a slope. If we're given the right kind of information, of course, if we have enough information, we can figure out if we have an angle and a side, we can figure out all of the sides and all of the angles of a right triangle, of course. So let's look at this picture right here. And in this picture, you're going to see that we have, let's say that this is a road that you're trying to measure, and you're able to measure this distance over a slope. And the grade of this is alpha. Well, the angle is alpha. And we're trying to calculate h. H not being hypotenuse, don't get confused, but being the horizontal distance, which will always be smaller than my slope because, well, as we know from right triangles, if this is my right triangle, and this is S, and this is H, H will always be greater than H. The hypotenuse is always greater than either one of the sides. So with that in mind, there is a way to approximate what the correction is going to be, given that the grade is not greater than 10%. But we can also make this correction using trigonometry. So from this figure, a tape length S is stretched along a slope, and H is the distance that you want to measure. So you were only able to measure S, but you want to calculate H by making either a correction or by using trigonometry and just determining H. The correction you need to make is C. Some textbooks provide the following approximation. So C is equal, C for correction, excuse me, negative V for the vertical change squared over 2S, where S is the slope that you measured. However, when the gradient is greater than 10%, this approximation will cause a large error margin, and therefore trigonometry is preferred. So we're going to do it both ways. Also, note that this correction always has a negative sign, so because the actual horizontal distance is always shorter than the calculated slope. All right, so this one says, a distance was measured as 1352.44 on a 3% slope or grade. What is the horizontal distance measured? So let's say that we have a triangle, and this triangle looks like this. So we're going to do it two different ways. Actually, yeah, we will. So let's say that this is my triangle. And this triangle is, the grade is 3% grade, so 3% grade. And you were able to measure the horizontal distance, and you found it to be, oh, 1 second. I am looking something up in my book real quick. Yes, nothing. Never mind. Okay, this is 1352.44. So let's apply the correction with the approximation because this is a very small grade. Also, whether you use the approximation or trigonometry will depend sometimes on the information you're given. If you're given a grade like this one, it is better that you use this method because this does not mean, this means 3%, not 3%, a change of 3 for every 100 feet, right? Yes. So this is the kind of correction where you still have to, you do it for every 100 feet, but then you multiply that times how many times you have to measure your 100 feet. So this is a little bit different than if you were already given an angle. So here we said that it was going to be negative V squared over 2S. Now S in this case is not this number. S stands for each one of our measurements, and if our tape is 100-foot tape, then this is going to be 100 right here. And V is a vertical distance. Now, if you notice here, we weren't given a vertical distance, but if you remember what this meant, this means 3 feet per every 100 feet that we measure. So, oops. So this means that this is actually 3 because we're doing, each one of these corrections is for every 100 feet that we measure. So 2 times 100, oops, and this is negative 9 over 200, which is equal to negative 0.045. But this is just for 100 feet. So now we're going to multiply negative 0.045 times, well, how many times did we make this measurement? 13.5244 times. And this is going to give me negative 0.6086. And remember, right now I'm just keeping extra digits for precision. Later I will adjust that. But now what I have to do is to find my final number, it's going to be 1352.44 minus 0.6086, and I end up with 1351.83 approximately. So this is my new, so this is my adjustment, and this is my new adjusted measurement. Now it's the difference is very little because we have such a small grade. So really this is a slope that looks like this. So this is my horizontal distance, and this probably looks like this. So of course, and I'm terrible at doing straight lines with this, but the difference between the horizontal and the slope isn't as marked, and if we have like an angle of 45, right? So anyway, that's one method to do it because I was given a grade. Now I'm going to give you another example where we're going to be given an angle, and in that case we can use trigonometry. So let me erase this, and let's do this problem right here. If the angle of a slope is measured to be 4 degrees 12 minutes, and the slope distance with a steel tape was found to be 2317.43 feet, what is the horizontal distance? So in this case, first of all, let's convert our angle from this format to 4 degrees 0.12 over 60. This is equal to 4.2 degrees. So now I can use kind of what I've done in the past, where this is my triangle, and this angle is 4.41, um, 4.2, and this distance is 2317.43. So now I can use, there's several different ways I can do it, but really the easiest way is just to go, well, oh, I thought I had it in my notes. Apparently I don't. Oh yes, I do. So if I want to find the horizontal distance h, I can do, well, I have this angle, so I can use sine of 4.2 is equal to, actually I don't want sine, let's do cosine, because this is adjacent. Sine would give me this one, and then it would still be one step away. Cosine of 4.2 is equal to my adjacent side over the 2317.43, and if I multiply this times that, h is equal to cosine of 4.2 times 2317.43. I get 2311.21 feet. And that's it. All right. Let's see, how much time have we spent? Okay, well, I'm going to stop this video right here, and we will continue with more corrections in the next video.